This is question 20 off of page 398. A clinical trial was conducted to test the effectiveness of the drug zopiclone for treating insomnia in older subjects. Before treatment with zopiclone, so this is to establish a baseline value, 16 subjects had a mean wake time of 102.8 minutes. After the treatment with zopiclone, the 16 subjects had a mean wake time of 98.9 minutes and a standard deviation of 42.3 minutes. Assume that the 16 values appear to be from a normally distributed population and test the claim that after treatment with zopiclone, subjects have a mean wake time of less than 102.8 minutes. And then when we're all done with this, we're going to answer whether or not zopiclone appears to be effective. So first, for the claim involves the mean. So we can get rid of the proportion, we can get rid of the standard deviation, and they say that that is less than 102.8 minutes. And if it is the mean in the claim, then it's the mean in the hypothesis statement. And if it's 102.8 in the claim, then it's 102.8 in the hypothesis statement. In the null, it is the equal because it's always the equal. And in the alternate, it has to be a strict inequality. And our claim is a strict inequality, so that less than just gets to drop right down in there. And it's the alternate this time that represents the claim. Now, the tail of the test, since the alternate hypothesis is pointing to the left, this is a left tail test. Our value of alpha is not given here. And whenever we get a significance level that's omitted, we can always go back to our default. So here we're going to go with our alpha, or if we want to write that symbolically, we're going to use 0.05, and hopefully our choice of alpha doesn't become an issue, but we'll see how things play out. And then our sample information, and our sample size was 16 adults. Our sample that we're interested in is those that have had the treatment, so our mean here, our sample mean, X bar, is the 98.9 minutes, and it was our sample standard deviation, that's 42.3 minutes. Now, a rule of rejection, using p-value versus significance level, we will reject the null hypothesis if the p-value is less than or equal to whatever we set our alpha at. Again, that was 0.05. And in terms of our test statistic, we're testing means, and with our sample size being less than 30, we needed to know that the values appear to be from a normally distributed population. If we didn't have that, we would be done here. Now, since we're working with the mean, that's going to be either Z or T, and whether it's Z or T is going to be driven by which standard deviation we're using. Since we're using the sample standard deviation, we're going to be using T. And if you weren't sure about that, no big deal, because we're about to see, when we go over to a hypothesis testing mean one sample, when we start entering our information, so our alternate hypothesis, population mean less than the claim mean, and our claim mean is the number in the claim, 102.8. Since we don't know the population standard deviation, StatDisk is going to tell us which distribution we were using. Sample size was 16, sample standard deviation 90, sample mean 98.9, sample standard deviation 42.3. We can hit evaluate and plot. And it told us that we're using the t-distribution. So again, StatDisk wants to be our friend if we will let it be our friend. and the corresponding p-value. So here our p-value was almost 36%. So we're only going to reject the null hypothesis if the p-value was less than or equal to 5%. It is not, so we are not rejecting. We fail to reject the null hypothesis. And now when it comes time to write the conclusion, there's two things that we're looking at to start this off with. Whether we rejected or failed to reject the null hypothesis, that's going to tell us whether or not we have the evidence. And then where in the hypothesis statement is our claim represented. It's in the alternate, so it's going to be about whether or not we can support this claim. We failed to reject, so we don't have the evidence. So we have insufficient evidence to support the claim that, and then for the rest of that, we can literally just cut and paste what the claim was. So we're concluding we don't have enough evidence to support the claim that the mean wait time decreased. And since that's the whole point of the drug is to decrease the mean wait time, then our answer here is no, we don't have enough evidence that the mean has actually decreased. So we don't have enough evidence that the drug actually works.